Claudio is an associate professor here at Computer Science. He's one of the world's leading experts on cryptography and provably secure distributed computation. So please welcome Claudio.
Thank you, Jesper, and thanks to all the speakers before me. So, what did Jesper just tell us? You can think of the blockchain. What is the blockchain? The blockchain can be seen as a distributed, immutable, write-only memory, right? So you can write things on the blockchain, and they will stay there forever. And no one can change them, and they're there for good. This makes a blockchain the perfect tool if you want to record and store important information, such as, for instance, financial transactions. So the fact that it's immutable is very important because imagine I'm selling you my car, right? We write the transaction on the blockchain. Let's do it here. Imagine I'm selling you my car. We put the transaction on the blockchain, and then we can you can make sure that tomorrow I cannot just go and claim that go back on the blockchain, delete the transaction, and claim that you stole my car. So that's nice, right? And blockchain technology guarantees this even if a fraction of the network is under attack or is corrupted. So that's great. But at the same time, the fact that all the transactions are there and are stored forever, it's a very, very, very big problem for privacy. So if you think of Bitcoin or any other first-generation cryptocurrency, they have huge problems with privacy built in from the start. It has been said that Bitcoin is like Twitter for your bank account. And this is a very good analogy because every time you do a transaction, this just gets sent to all other machines in the network, right? Not only it's sent to all the machines in the network, then it's like saved and stored on the blockchain forever, accessible to everyone. There is this misconception, and many have said that you can still go on lots of websites and they will say that Bitcoin is an anonymous cryptocurrency. It's not. This is a very big misconception. The guarantee that Bitcoin gives is called pseudonymity. So what is pseudonymity? Pseudonymity means that on the blockchain, you will not see my name. You will not see a transaction from Claudio Orlandi to Jesper. On the blockchain, you will see some random-looking strings. We call them addresses. And you can think of them as being the bank account number of the users on Bitcoin. So it means that when you go on the blockchain, you will see all these addresses, all these bank account numbers, making transactions between each other. So of course, when you look at a transaction, you don't know that it's mine. But as soon as you make a transaction with me, you will learn my address or my bank account number. And therefore, there is no more privacy left for you on the blockchain. As an example, look here on the right, left. How does it work? This is an abstract view of the data that is available on the blockchain, for instance, for Bitcoin today. You can see that there are some addresses. You can see that A123 sent some money to B498, when it sent it, how much it was sent. And then all of this information is digitally signed using proper cryptography to make sure that it comes from the right people. Of course, when you look at this table, you don't know what's going on, right? But let's suppose that the first transaction here is Aarhus University paying my salary. So A123 is Aarhus University, and B498 is me. And now I have to be careful because Kai, my employer, is here in the room. So let's say that once Kai pays my salary, right, he will learn that I'm user B498. But now Kai can go and look at the blockchain and see that after 2 hours, I went and spent 3 coins in this shop, and then I went and spent another coins in this other shop. And then, again, I have to be careful because I love Aarhus University, I love my employer, but I don't think that my employer should know when and how I spend my money, right? As well as no one else that I transact with, right? When I go into a shop and I give them some money, they shouldn't be able to go back and trace where did I get my money from. Just because I buy a pizza here doesn't mean I want them to know where I work or how much my salary is or any of this information, right? All this information, which is publicly available on the blockchain, can also put a big target on your back. For instance, if you have a lot of money, right? It makes a very, very good target for people that want to steal your money to know exactly how much money you have. So all of these problems are clear problems if you want to use Bitcoin or any of the other first-generation cryptocurrencies in real life. Because of this, there's been a second generation of cryptocurrencies which have built embedded from the beginning guarantees of privacy and anonymity. There are several examples out there. And the way this is achieved is by, instead of putting all your information on the blockchain, you can encrypt the transaction on the blockchain. And I'm doing this at a very, very high level. I can talk for hours about how this is done, and I would love to do it if you're interested afterwards. But let's just say that all the transactions are just put encrypted on the blockchain. And then through some crypto magic, something non-zero knowledge proofs, you can prove that you have enough money to transact and you're sending the money to the right people and so on. So this is great for privacy. But is this good as a society? It's not a secret that the perceived anonymity of Bitcoin and the true anonymity, which is provided by other cryptocurrencies, has attracted people with bad intention to this kind of technologies. Bitcoin have been involved in criminal activities, money laundering, tax evasion, and so on. Couple of quick examples of these. The Silk Road. So Bitcoin hit the mainstream media back in 2013 when, because of its association to the Silk Road, which was an anonymous marketplace online where people could buy illegal things like drugs or killers or other things that we don't want to necessarily support in society, right? Another example is from a couple of years ago. In the last couple of years, especially Denmark has been hit quite hard by ransomware. There were many companies, both in the public sector and private companies, who were hit by this ransomware, which essentially is some malware which encrypts all your files on your machine and then says, I'm only going to let you get your data back if you pay me all of this money in Bitcoin. So this is a problem, right? There is a problem of accountability. There is a problem of, you cannot go back and look at, who did what, and law enforcement cannot go and do the job because of this. So some of the research challenges that we are going to address in this work package are the design of novel cryptographic techniques, which can be used to perform secure transactions over the blockchain. We're going to do this in the standard methodology of cryptography, which is to define precise mathematical models of which security properties we need, both thinking about current threats, but also thinking in the future for future threats, for instance, post-quantum cryptography, how to build cryptographic schemes which will be secure also if or when quantum computers will be available. And then we're going to mathematically prove that the schemes we build are secure according to this definition. And from this point of view, our group has decades of experience in doing this kind of research in the designing advanced cryptographic primitives such as digital signature schemes, threshold cryptography, privacy-enhancing technology, zero-knowledge protocols. And for us, it's very exciting to take all of this background that we have and go and apply to this new application domain in blockchains. Something else we're going to work on is identity management. So as I hinted, there is a problem of accountability with current blockchains. So some of the research challenges, some of the research goals we have here are to design new cryptographic tools that allow users to create, store, and manage their identities on the blockchain. So the goal here, of course, is that from one side, we want to be able to keep users' identity, their balance, and their transaction history private from unauthorized users, right? No one should know. I mean, I don't want anyone, I don't want everyone in this room to be able to know what and when, what I buy. At the same time, we want to be able to allow users to selectively prove statements about their identities. For instance, it can be convenient to be able to prove that you're over 18 if you want to buy a bottle of wine. So in some cases, you want to leak partial information about the identity as is required by legislation or other concerns. But we want to do this in a way that users will still be accountable for their actions so that this is not an anonymous system, but it's an accountable system. It's a private and accountable system. To conclude, I would like to say something about cryptography because I think that there is often some misconceptions, both in the media and for lawmakers. So cryptography is not about helping the bad guys hiding what they're doing, right? I think we can all agree that not everyone should have access to all data. When I do a transaction online, I don't want hackers to steal my credit card number. If I take pictures of my kids and I send them to their grandparents, I don't want other people to be able to get these pictures, right? So some people should have access to some information, some other people should not have access to this information. And cryptography is the necessary tool which allows you to enforce these boundaries, regardless of then how we decide to put these boundaries as a society.